So I want to talk about a little bit more about stratified design. Hi, my name is Eric Normand, and these are my thoughts on functional programming. So a few episodes ago, I explained something that I called layered design, and I did a little bit more research about it, and it turns out it's actually got a different name. It's called stratified design, and there's a whole chapter on it in structure and interpretation of computer programs. And strata and layers, they mean the same thing, and so I just used the wrong term. Um, but I do want to talk a little bit more about it in more detail, and to really talk about it as an architectural pattern. I talked about it in terms of organizing your code, but as an architectural pattern, I think it's useful to from that perspective, like to talk about it. So just to recap really quickly, in stratified design, you start with your base language at the bottom, right? The stuff your language gives you, maybe the standard library, the data structures you've got, functions, for loops, whatever you've got. And then on top of that, you build a layer of meaning. So whatever, and I don't want to give an example yet, but I will. So then after that, you build another layer of meaning on top of that layer. And you continue building layers of meaning until you're at the layer of meaning where your problem, the solution to your problem is very clear and concise, and you can, experiment with it at the right level of meaning, of abstraction. And that's stratified design. So one thing that you'll see in stratified design often is that in a business context is that you're defining, say, at the bottom level, a very sort of data model driven system. And then on top of that, you're adding some business rules. And then sort of at the top layer, I would say the top, but there's probably more layers in between, where you have primitives that you then add on into combinations of those primitives, until you have at the top of your strata, your layers, the top layer is dealing in business rules, because that's the stuff that changes the most. And so this strata idea also talks about like where things change, the speed at which things change. Notice the bottom layer is the language. That's the thing that changes the slowest, right? Like even if, a language is getting released all the time, it's not changing that much over time. Whereas your business rules, depending on the market conditions, depending on your business strategy, that could be changing all the time, right? And then the stuff underneath the business rules is a little bit more stable, and it's going to, because it needs to be more stable to build the business rules on top of. So as you go down, things get more stable. And so this lets you sort of, gut check. You might even be able to make metrics about this. If you could say, figure out a diagram, automatically generate a diagram from your code based on dependencies, how things change and what layer it should be at. Like, ooh, this is weird. This thing is at a high layer, but it changes slower than this other thing that it depends on. So maybe there's something wrong there. It would just kind of highlight these code smells. Structurally, another thing that happens is that your dependencies all point down. Otherwise, it's not really a layer. They don't point sideways. That's another aspect of it. So you could have two, say, modules at the same level of meaning, the same strata, but since they're at the same strata, they have no dependencies between them. right? But then something on top might depend on both of them. Okay. And so there's a directionality to the dependencies, and there's also a potential code smell in there, which is if you skip layers, right? Meaning, like, you start writing your business rules with the lowest level language constructs, right? When you really should have multiple layers in there, and this kind of comes in even when you haven't started with stratified design. It's a code smell, right? Why am I using a for loop to determine the direction my business is going to take, right? You should be doing something higher level. You shouldn't be in there writing your business on assembly, right? You're skipping too many levels. Right, so let me give an example that's not code related of this kind of stratified design. So I like to cook. I'm not that good at it, but I like to cook. And I like to cook from different cuisines. You know, I like New Orleans cuisine, where I'm from. I also like Vietnamese cuisine and Chinese cuisine, Indian, French, Italian. I like all sorts of stuff. And I also like looking at what's happening with a lot of modern cooking, which is like breaking stuff down even further into like the chemicals. You know, you start learning some chemistry. And so it turns out, like, if you start to map this out, you've got this base layer at the bottom, which is, let's just call it chemistry. So you're starting with proteins and lipids and heat and like these and acids and bases. Like, all these chemistry items are at the bottom. These things change the least, right? Like, nothing's gonna change chemistry. And then on top of that, you add sort of your basic techniques, let's say. So this would be like how to apply heat to something, right? We're not talking about the something yet, but how to apply heat, and like the properties of your tool, like your pan can transfer heat at a certain rate with a certain, you know, you're looking at this layer that's built on chemistry, because heat transfer is a chemistry thing, but now you're talking about a pan, which is decidedly not like chemistry itself. It's a layer on top of chemistry. And then on top of that, you might have a layer that talks about the sort of preparation of ingredients, right? So, and I'm not saying like the ingredients themselves. That's probably either a layer below it or an adjacent layer in the same layer, but an adjacent module. So this is stuff like chopping techniques, like process milling, boiling, you know, those kinds of things that are built out of these like very basic techniques, like applying heat or cutting. But you know, it's something more like, okay, we're talking about chopping in one layer, and then the next layer we're talking about Julian, right? So it's not just like how to cut in a vertical, you know, a very basic thing. It's this other idea of like the kind of shape that you're trying to achieve out of your carrot, right? And so then on top of that, you're gonna have certain like basic recipes, stuff like how to make a sauce, like a very basic sauce, how to, you know, and so then on top of that, you're gonna have stuff like your dishes, right? This is gonna be, you know, I like to think of gumbo, right? Because I cook gumbo or jambalaya or something like that. These are the dishes that are made out of these components, right? So with a gumbo, you always start with a roux. And a roux is like a basic technique because other dishes have roux in them as well. Okay, so then that's like a really high level. You could go higher, and you could start talking about like how to prepare a whole meal, which is going to talk. It depends on knowing how to prepare dishes, right? So your meal is like, well, I need an appetizer, and then the main course, and then a dessert, right? And so you need dishes that that fall into these categories. Okay, I think you get the idea. And so this is what I do when I'm programming, what functional programmers do, is they start to identify these layers. And then there's this code smell that if you're defining your jambalaya recipe in terms of chemistry, you've skipped layers, right? You can't build up grains of rice from like proteins and starches and water, and you're not gonna do that. You're not thinking about the chemistry in that way when you're talking about jambalaya. You are thinking about it only one level. The chemistry is there, but you're usually only going one or two layers down. And so what this lets us do is build these things. One, they're understandable. Two, they're capturing this notion of frequency of change, which is huge when you're talking about architecture. Architecture is isolating changes that don't need to be done together, right? So if you isolate, you could here's a really good example. You go to a different part of the world, you have a different cuisine. Chemistry is not going to change, right? Maybe the ingredients, you add some, but like a carrot is still a carrot, right? There's new ingredients that are going to be added to the same level, but you're not changing like the basic, like you're not changing how carrots work. You're not changing how cutting works. You're not changing how your pan works, right? All those things are staying the same. And then, there's going to be at the top level, you are going to be, changing stuff and you're just a lot more churn in how things are defined. And then, of course, you're probably going to throw out all the recipes and start with totally new recipes. And so that's how your code should be structured as well. That you should be making these layers, these strata of meaning, and identifying them so that you're grouping them together in whatever is the appropriate way to group stuff in your language. That might be a module or a library or a namespace. It just depends on what you're doing. And then you also might get some help from your language, because in some languages you can have circular dependencies, and so you're going to enforce a certain direction to your dependencies, which is perfect. All right, so this is part one of what I think will be a 3-part series on functional architecture. So stay tuned. I'd love to hear examples of where you've used this stratified design. Like I said, I'm taking the name from Structure and Interpretation of Computer Programs, so it has a really nice pedigree. That's my opinion. And I'd love to hear from you. I'm on LinkedIn. Just search for Eric Normand Closure, and you'll find me. On Twitter, I'm at Eric Normand. Follow me, tweet at me. I'd love to get into discussions. You can take the discussions to email. I'm eric@lispcast.com. Be sure to subscribe and share this episode with your friends. All right, thank you so much.